shape of the molecule plays a very important role in the function of the molecule. Shape can be determined from the structure of the molecule. So in this section of this chapter, we're going to learn how to draw Lewis structures of molecules and how to get shapes from the structures. So these are the 9 steps involved in drawing the structure of a molecule. So we're going to go over them one after the other. So we're going to work on drawing structure of the compound carbon dioxide. We all know this compound. This is the gas that we breathe out, and this is the gas that is used by vegetation. Plants use this. So we're going to learn how to draw the structure of this molecule as an. The first step is to get the total number of total number of electrons that must appear in the structure. So now, how do you get the total number of electrons? There are 3 atoms in this molecule. So the molecule is carbon dioxide. There's 1 carbon atom and 2 oxygen atoms. So I'm going to write it as carbon, oxygen and oxygen. Okay, 1 carbon and 2 oxygens. And I removed that 1 because I'm just writing each element separately. Now, if you go back and check on your periodic table, there are 4 valence electrons on carbon. There are 6 valence electrons on oxygen. So in this molecule, totally there are 16 valence electrons. So the answer for your first step, determine the total number of electrons that must appear in the structure. So there should be 16 electrons in the structure. So you should see all the 16 electrons in the. Now the second step is decide if electrons needed to be added or subtracted, and add and subtract accordingly. If you think about it, carbon dioxide is a neutral molecule. It's not an ion. It's a neutral molecule. So we don't have to add or subtract electrons. So second step, no. No addition or subtraction of electrons. There are total 16 electrons that need to appear here. Third step is identify the central atom. So think about it. When you write the structure, how should the structure look like? Oxygen in the center and carbons like this? Or carbon in the center like this? Or another oxygen in the center like this? Okay. What is going to be your central atom? The rule is that central atom, the general rule, central atom is the atom with less electronegativity. Okay, that's the first rule. The second rule is that hydrogen never a central atom. Central atom. Hydrogen can never be a central atom. The other rule, carbon always the central atom. Okay. So now your structure is carbon dioxide. So carbon is always a central atom. So this is going to be your central atom, and this is going to be your skeleton structure with carbon as the central atom. So you've done the fourth step as well. Central atom and the skeleton structure. So this is what it's going to look like. Okay, so this is your skeleton structure. This structure tells us what atom is bonded to what. So this tells us that carbon is in the center and oxygen is on either sides of it. Now, if you look at this, you connected carbon and oxygen with one line, and this is a bond. Remember, one bond is always equal to 2 electrons. Okay, this is another bond equal to 2 electrons. So in this process, you used up 4 electrons, right? We originally had 16 electrons, and then we used 4 of them. So now we're left with 12 electrons. Now with the remaining 12 electrons, complete the octets of the terminal atom. Remember, octet means 8 electrons. So your original is like this skeleton structure. With the remaining 12 electrons, you complete the octets of terminal atoms. So terminal atoms are the atoms that are not the central atom. So we have 2 terminal atoms. This one right here and this one right here. Oxygen and oxygen. So with the remaining 12 electrons, we need to complete the octet for each one of them. So what we're going to do is we'll distribute those 12 electrons equally. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're done. We used up all the 12 electrons. Now, did we complete the octet of these oxygens? Let's check. Remember, one bond is 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. This oxygen also has 8 electrons.